of grade 3 secondary, welcome to our math program. Today we have calculus. Our lesson today is implicit and parametric differentiation. Let's start with the implicit differentiation. When we say that y equals 2x minus 5 over x minus 4, where x naught equals 4, then this function y is a function in x. And y is a differentiable function with respect to the variable x, and it's called a direct function in x. But the equation xy minus 3y to the power 2 minus 3x to the power 2 plus 2 equals 0 is called an implicit relation between x and y. And this relation expresses the relation between the two coordinates of point x and y lying on its graphical curve. Dear students, remember that given that y equals f of x is a differentiable function with respect to the variable x, then the derivative of y to the power n equals n multiply y to the power n minus 1 multiply the derivative of the function inside the bracket, which is dy dx, or the derivative of y power n with respect to the variable x equals n multiply y to the power n minus 1 multiply dy dx. For example, the derivative of y to the power 10 with respect to the variable x equals 10 y power 9 is the derivative of y power 10 multiply dy dx, which is the derivative of the function inside the bracket. Now, if the variable y power 10, we need to differentiate this function with respect to the variable x, we must be write dy dx because the differentiation is with respect to the variable x. But the derivative of y power 10 with respect to the variable y. Now, we need to derivative y with respect to the variable y. Then, the derivative of y to the power 10 with respect to y is 10y to the power 9. And the differentiation here is with respect to the variable y. Now, what about the derivative of y to the power 10 with respect to the variable t? Yes, the derivative of y to the power 10 is 10y power 9 multiply dy dt because the differentiation is with respect to the variable t. Now let's start with the first example. If x power 2 minus 4y power 2 plus 7 equals 0, find dy dx. This relation x power 2 minus 4y power 2 plus 7 equals 0 is called the implicit relation between the two variables x and y. By differentiating both sides of the equation with respect to the variable x, then the derivative of x power 2 is 2x, and the derivative of negative 4y power 2 with respect to x is negative 8y dy dx, and the derivative of 7 equals 0, and the right hand side equal 0. Now, negative 8y dy dx equals negative 2x. And the first derivative dy dx multiply dy or dy multiply dy dx equals 2x, then dy dx equals 2x over 8y, and in the simplest form dy dx equals x over 4y. Another example, if x power 3 plus y power 2 minus 7x plus 5y equals 8, then what is the value of dy dx? Find dy dx. The implicit relation x power 3 plus y power 2 minus 7x plus 5y equals 8, and we can differentiating both sides with the equation or of the equation with respect to the variable x. What about the derivative of x power 3 with respect to x? Is 3x power 2. And the derivative of y power 2 with respect to x is 2y dy dx. And the derivative of negative 7x is negative 7. And the derivative of 5y is 5 dy dx. Equals the derivative of 8, which equals 0. Then the derivative of x power 3 plus y power 2 minus 7x plus 5y equals 8 is 3x power 2 plus 2y dy dx minus 7 plus 5 dy dx equals 0. Now we have two terms included dy dx. Then we can take dy dx as a common factor in the left hand side. Then dy dx multiply between two bracket 2y plus 5 equals, in the right hand side, 7 minus 3x power 2, which is the two terms free of dy dx. Now dy dx equals 7 minus 3x to the power 2 divided by 2y plus 5, which is the first derivative of the implicit relation x power 3 plus y power 2 minus 7x plus 5y equals 8. Another example, if x power 3 plus 6xy equals 4y plus 3, find dy dx. The implicit relation x power 3 plus 6xy equals 4y plus 3, we can differentiating both sides of the equation with respect to the variable x. Then, what is the derivative of x power 3? Yes, 3x power 2 plus 6xy is the product of two functions. We can take 6 as a common factor. Then, what is the derivative of x multiply y, product of two functions? Product of the first, derivative of x equals 1, multiply the second, multiply y. Then the first term is y, plus the second, multiply the second, times the first, or the first multiply the derivative of the second. The first is x, and the derivative of the second is dy dx. Then the derivative of x times y is y plus x dy dx between two brackets equals, in the right hand side, the derivative of 4y is 4 dy dx. 4 is a coefficient and the derivative of y is dy dx, plus 0 is the derivative of 3. Now 3x power 2 plus 6 multiply y equals 6y, and 6 multiply x dy dx equals 6x dy dx equals 4 dy dx in the right hand side. Now 6x dy dx minus 4 dy dx equals negative 3x power 2 minus 6y. We can take dy dx as a common factor in the left hand side. Then 6x minus 4 between two brackets multiply dy dx equals negative 3x power 2 minus 6y. and dy dx equals negative 3x power 2 minus 6y over 6x minus 4, which is the derivative of the implicit relation x power 3 plus 6xy equals 4y plus 3. Another example. If x over y plus y over x equals 1, find dy dx. Now we have x over y plus y over x equals 1 is an implicit relation between the two variables x and y. We can multiply both sides by xy. Then we get the relation x power 2 plus y power 2 equals xy. Because x over y multiply xy equals x to the power 2 plus y over x multiply xy equals y power 2 and 1 multiply xy equals xy. Now, by differentiating both sides of the equation with respect to the variable x, we get the derivative of x power 2 with respect to x equals 2x. And the derivative of x power 2 with respect to x is the derivative of y power 2 with respect to x is 2y dy dx equals the right hand side is the product of the two functions x and y. Derivative of x equals 1 multiply y plus x multiply dy dx. Then 2y dy dx minus x dy dx equals y minus 2x. And by taking dy dx as a common factor in the left hand side, then between two brackets 2y minus x multiply dy dx equals y minus 2x. Then the first derivative dy dx equals y minus 2x over 2y minus x, which is the derivative of the implicit relation x over y plus y over x equals 1. Now we move to the next example. What is the derivative of sine 2x with respect to the variable x? The derivative of sine 2x with respect to the variable x is 2 cosine 2x. By differentiations both sides with respect to x. What about the derivative of cotan 3y with respect to the variable x? By differentiating both sides with respect to x, then the derivative of cotan 3y with respect to x is negative 3 cosec power 2 3y times dy dx. The derivative of cotan 3y is negative cosec power 2 3y. And the derivative of the angle 3y with respect to x is 3 dy dx. And we can write the derivative in the simplest form, negative 3 cosec power 2 3y multiply dy dx. What about the derivative of sec by theta with respect to the variable x? The differentiation is with respect to x. Then the derivative of sec by theta is sec by theta tan by theta multiply the derivative of the angle. What is the angle? The angle is by theta. The derivative of by theta with respect to the variable x is by d theta dx. Now we move to another example. X cosec y equals y cotan x. Find dy dx. Now we have product of two functions, x multiply cosec y in the left hand side and y multiply cotan x in the right hand side. we can deduce the rule of the product of two functions in both sides. Now, what is the derivative of x? Remember that the differentiating here both sides with respect to the variable x. Then, the derivative of x is 1 multiply cosec y plus x multiply the derivative of cosec y. X multiply derivative of cosec y with respect to x is negative cosec y cotan y multiply the derivative of the angle. The angle here is y. The derivative of the angle y with respect to x is dy dx. Then the derivative of the left hand side x cosec y is cosec y plus x multiply negative cosec y cotan y dy dx. In the right hand side we have product of two functions y multiply cotan x. The derivative of y with respect to x is dy dx multiply cotan x plus y times the derivative of cotan x with respect to the variable x is negative cosec power 2x. Then we can write the left hand side cosec y minus x cosec y cotan y dy dx equals the right hand side dy dx cotan x minus y cosec to the power 2x. Remember, we need to find dy dx in one side. Then we can write cosec y plus y cosec power 2x in the left hand side equals dy dx multiply cotan x plus x cosec y cotan y dy dx in the right hand side. And we can take dy dx as a common factor in the right hand side. Multiply between two brackets cotan x plus x cosec y cotan y. Now dy dx equals cosec y plus y cosec to the power 2x over cotan x plus x cosec y cotan y, which is the derivative of the relation x cosec y equals y cotan x. Now, what about parametric differentiation? If the x coordinate and y coordinate of the point x and y can be expressed as a function in a third variable t, it's called the parameter by the two equations x equals f of t and y equal g of t, where f and g have the same domain. The two equations together represent an equation of one curve expressed in the parametric form. For the curve given in the parametric form, x equals f of t and y equal g of t, we can find the first derivative dy dx as a chain rule, which equals dy dt multiply dt dx, or dy dx equals dy dt divided dx dt, which is the parametric differentiation, where f and g are two differentiable functions with respect to the variable t or with respect to the parameter t. Let's start with the first example. Find dy dx for the following curve at the given value. X equals 13t minus t to the power 2, y equals 6t power 3 plus 7 at t equals 5. Now we have two equations. The first equation, x equals 13t minus t to the power 2. This equation in terms of the variable t or the parameter t. Then dx dt equals derivative of 13t, which is 13, and the derivative of negative t power 2, which equals negative 2t. The second equation, y equal 6t to the power 3 plus 7. Then dy dt equals the derivative of 6t power 3, which is 18t power 2, and the derivative of 7 is 0. Then dy dt equals 18t to the power 2. Now dy dx equals dy dt multiply dt dx, chain rule, or equals dy dt divided dx dt, which is parametric differentiation. Now dy dx equals 18t power 2 divided 13 minus 2t. When t equals 5, then dy dx at t equals 5 equals 18 multiply 5 to the power 2 over 13 minus 2 times 5 equals 450 over 3, which equals 150. Now we move to the next example. Find dy dx for the following curves at the given value. X equal sine 2 by theta, y equal cosine 2 by theta at theta equals 1 over 6. The first equation, x equals sine 2 by theta. What is the derivative of x with respect to the variable theta? dx d theta equals derivative of sine 2 by theta equals 2 cosine 2 by theta. What is the derivative of cosine 2 by theta? What is the derivative of sine 2 by theta is cosine 2 by theta times the derivative of the angle. The derivative of the angle 2 by theta with respect to theta is 2 by. Then dx d theta equals 2 by cosine 2 by theta. The second equation, y equals cosine 2 by theta. The derivative of y with respect to theta, dy d theta equals, what is the derivative of cosine 2 by theta? Negative sine 2 by theta is the derivative of cosine 2 by theta. And the derivative of the angle 2 by theta is 2 by. The derivative here with respect to theta. Theta is the parameter. Then the derivative of cosine 2 by theta equals negative 2 by sine 2 by theta. Now dy dx equals dy d theta times d theta dx, or equals dy d theta divided dx d theta. Then dy dx equals negative 2 by sine 2 by theta, which is the derivative of y with respect to theta, over 2 by cosine 2 by theta, which is the derivative of x with respect to theta. We can cancel 2 by from the numerator and denominator. Then dy dx equals negative sine 2 by theta over cosine 2 by theta. And we know that sine 2 by theta over cosine 2 by theta equals tan 2 by theta. Then negative sine 2 by theta over cosine 2 by theta equals negative tan 2 by theta. Now dy dx at theta equals 1 over 6 equals negative tan 2 by multiply theta or multiply 1 over 6. which equals negative tan pi over 3. Pi here is the angle. Then tan pi over 3 equals tan 180 over 3, which equals tan 60. Tan 60 equals root 3. Then negative tan pi over 3 equals negative square root of 3. Example. Find the value of the parameter t at which the curve x equals 2t power 3 minus 5t power 2 plus 12, y equals 2t power 2 plus t minus 4 has a horizontal tangent. Number 2 has a vertical tangent. Now we have x equals 2t power 3 minus 5t power 2 plus 12. Then the x dt equals 6t power 2 minus 10t. And we have y equals 2t power 2 plus t minus 4. Then dy dt equals 4t plus 1. dy dx equals dy dt multiply dt dx, or equals dy dt divided dx dt. Then dy dx equals 4t plus 1 over 6t power 2 minus 10t. The first required, the curve has a horizontal tangent. Then the slope of any horizontal straight line parallel to the x-axis equals 0. Then dy dx equal 0. Then 4t plus 1 over 6t power 2 minus 10 equals 0, or the numerator 4t plus 1 equals 0, then t equals negative quarter. In the second required, the curve has a vertical tangent, and we know that the slope of any vertical straight line parallel to the y-axis is undefined, or equal any real number not equal 0 over 0. Then dy dx undefined 1 over 0. Then 6t power 2 minus 10t, which is the denominator, equals 0. And by taking 2t as a common factor, then 3t minus 5 between two brackets multiply 2t equal 0, and hence t equals 0, or t equals 5 over 3. And by this example, we come to the end of our program today, and till we meet again, it's goodbye.